Lesson 3, Circuit Schematics. We're going to skip the warm-ups for now, and we're going to go right to today's purpose. We're going to learn how to interpret diagrams of circuits. The relevance is that schematics are the way that engineers give directions for making circuits, and there are a lot of people out there that have hobbies of putting together different kind of car systems, car stereo systems, or other electronics. And so when you pursue that kind of a hobby, you're going to be looking at lots of different plans for the circuits. These are called schematics. Success. I will be successful in this lesson when I can label and draw diagrams for circuits. Number 1, what is a schematic diagram? A schematic is a type of a blueprint that shows the layout of the parts of a circuit. Now, just like an architect has different symbols for parts of a house or parts of a building to show you where the doors and windows and outlets and all that kind of stuff are going to be, an electrical engineer is going to have different symbols for different parts of a circuit and show you how to put them together. It's a little bit more loose than an architectural drawing, but some rules still apply. Number 2, how do you draw wires in a schematic? The lines are either going to be horizontal or they're going to be vertical. And they're going to have 90-degree corners. So that makes things look nice and neat. You don't want wiggly lines. You don't want diagonal lines. Either horizontal or vertical, nice sharp corners. Symbols. A resistor is a zigzag line. A resistor that can be altered, like the dimmer switch at your house or a volume control on a stereo or a television, has a little arrow on it. That kind of represents a needle that can go back and forth to pivot for the amount of resistance. Light bulb, we have a circle with a loop through it, and that is to try to mimic an actual light bulb. When you have an incandescent light bulb like this, if you look very carefully on the inside, you'll see a little wire, and that's why electricity flows through and makes it get really super hot really fast, and it's so hot that it glows. A battery, we have one long line and a short line that are perpendicular to the wire. That represents the two sides or two terminals of the battery. And then we have an AC outlet. We have a sine wave here. This represents the fact that with an alternating current, AC current from the outlets of our houses, the current grows stronger in one way and then weaker, and then it reverses direction and it goes in the other direction and then it gets weaker. So there's this back and forth motion in the current for AC. That's why they call it alternating current, AC. Okay, then we have a symbol for a button or a switch. You can kind of think of this as a drawbridge. When the drawbridge comes down and closes the gap, then you can ride horses and buggies across the drawbridge. When this little switch is down, it can carry a current. And the reason why we have this is because traditionally this is the kind of a switch that high schoolers and college folks have when they are learning all about circuits. This would be in the off position, and then this would be in the on position, where current can flow through here and over there and then onto another wire. Then we have the symbol for a motor, just a nice big old M, make it obvious. For a speaker or a buzzer, we have this trapezoid. That kind of represents the shape side view of a speaker cone. You can see that we have the slanted sides here, and so it kind of goes along with this symbol right there. And then a diode. A diode is a one-way street for current, and this little arrow shows us which direction current can flow through with very little resistance. If we try to send current the other way, going against that arrow, then the diode is going to exert a lot of resistance and basically turn off that current. Number 4, where are variable resistors found? This is in light dimmers. Some people have sliding switches to dim their lights. Other people have turning or rotating a knob. Either way. And you also have some volume controls, particularly the kind that have the twisting knobs. Those will be variable resistors. In terms of pressing the button to make it go higher and lower, I'm not exactly sure if that is going to be a variable resistor or a variable voltage. What are diodes? Diodes are one-way streets for current. Once again, if you have current flowing in the correct direction, the diode exerts very little resistance. If you try to put current through the diode backwards, it has an incredibly high resistance. Number 6. Remember, in a schematic, the exact location of the items in a circuit is not important. It is the order in which current flows that needs to be shown. So here we have a kind of like a picture showing us the different items. Let's turn this into a schematic where for each item I'm going to put the right symbol, and I'm going to change the wires so that they are shown to be vertical or horizontal with sharp corners. So here we have an outlet. That's going to be a squiggly line in a circle. And then I'm going to a light switch. So we have that symbol there. And then I have wire coming down, and I have 2 light bulbs. And then it goes back to the power supply. So this is a more literal view of the circuit here. Now, as we said before, the exact location of these items is not important. I could have drawn the light bulb over here, for instance. Current still flows through it in the same manner. Let me pull out another diagram or another circuit here to help illustrate this. So here I have a battery and 2 light bulbs in a very simple circuit. So you can see that if I gave you directions to draw this schematic, it would look something like this. With a battery, goes up to a light bulb, and then it comes down to another light bulb on this side and back to the battery. But if I had the circuit like this, now I have the 2 light bulbs in a row like that. Somebody might be tempted to draw the schematic like this. And that's perfectly fine. It doesn't matter if there's a bend in the wires between the 2 light bulbs or not. It is still going to be the same circuit when I wire it up. So the exact location does not matter. I could draw it like this, where I have the 2 wires or 2 light bulbs, the 2 light bulbs on the left side, the battery on the right side. It would look like this. These are all the same circuit. It doesn't matter how I have it arranged. It will operate in the exact same way. So you have a little bit of leeway. You figure out the way that the schematic would be most understandable, and that's the way you draw it. Let's look at letter B here. I always like to start off at the battery. So the battery symbol is that, and I have a wire going out, and then the wire breaks up into 2 branches. So I'm going to go 1 up, 1 down. The one that goes up has a push button, and it's going to have the same symbol as a switch. And then I have a fan, which obviously has a motor in it. So I'm going to put an M in the circle. And then after the fan, it comes back down, and it rejoins this other wire. Let's look at this lower wire here. It has just a light bulb on it. After the wires join together, I can have it come down here as this wire, and then we have another push button, and then it goes back to the battery. Another way of drawing this that is a little bit more compact would start off with the battery, go to the switch, go to the motor, and then come on down. And then to draw this branch, I would draw the branch here. After the light bulb, it rejoins up. So here, after the light bulb, it joins back up. And then we have our button switch, and then back to the battery. As you can see, this is a little bit less complicated looking than that. Either way, it doesn't matter. They're both correct. Okay, here I like to start off with the power supply, which in this case is the AC. And it comes out and we have 3 branches. 1, 2, 3. Each branch has its own light bulb. And then after the light bulbs, it rejoins to a switch. And after the switch, it goes back to the power supply. Letter D. Starting off with the power supply of a battery. Then it goes to a light bulb. Next thing is a push button. Two speakers. And then back to the power supply. Okay, try to do E and F on your own. Pause the video, give it a try, and then come back and see if you did it right. Here we have 2 batteries in a row. Comes up and we have a switch coming down to a light bulb. And then we have this other branch to show. It'd be best if these lines were continuous and nice and straight and horizontal, but I got a little bit sloppy there. How do you classify circuits? When a circuit is off, the circuit is an open circuit, and the flow of electricity stops. The reason why we call it an open circuit is because with these kinds of switches, you lift it up like this, and that breaks the bridge, so to speak. Current cannot flow from here down to there, and so current stops. We have a gap in the wires. And then when I want to start the current again, I close it up. Now current can flow up here, across, and down. So this is an open circuit. Things stop. And then when the switch is on, it is a closed circuit. I close it up to allow current to flow through. Besides open and closed, what are other ways of classifying circuits? Okay, we have a series circuit. All the current has no choices whatsoever. It has to go through the resistors one after the other. Circuit D on the previous page is this kind of a circuit. So right here, this one, current comes out of the battery. It has no choice. It has to flow through this light bulb, it has to go through the button, and then that speaker, and then that speaker, and back to here. There are no choices, no branches. So that would be a series circuit. The next one, number 2, is called a parallel circuit. Parallel circuit has branches. So 2 things are happening right next to each other, side by side, so to speak. Some current goes one way, some current goes the other, and it's not necessarily 50-50. It depends upon what's hooked up to these different branches. It says here that circuit C is a parallel circuit. And so here is circuit C. Let's label it parallel. And we can see that here we have this wire can be drawn to be parallel to that wire, which is parallel to this wire. Another definition of parallel, besides the geometry kind of a thing, is just simply that two things are happening at the same time. The two committees were working in parallel with each other. Could be another context, in other words, where two committees in some kind of a business are both doing tasks at the same time in different rooms. But anyway, parallel, we have these light bulbs working at the same time, but different parts of the circuit. Okay, so line number 3, label the previous circuits. On the top of the page here, go ahead and label each one of those as either being parallel or series, and then start the video up again and see if you are right. But right now, give it a pause. In this diagram, there is a branch. Even though there's nothing on this branch, no switches or light bulbs or anything, we still have a wire that's branching, and so that would be considered a parallel circuit. Line number 11, how do you draw a schematic for a simple flashlight? I'd like you to go up to the front of the room where I have a bucket full of these cheap little flashlights, and I have cut open the side of it so you can see the inside. When you flip the switches back and forth, I want you to see what's going on the inside. Look down the tube and on the other side and see what's going on there, and see if you can draw a schematic. Go ahead and pause the video and see if you can do that at this time. The switch, hopefully you can see down here that when you pull the switch backwards, there is a gap between this wire and this silver housing, and when I slide, it connects. So this is a type of a switch. It's going to have the same schematic diagram symbol as any other switch or a button. And then as it touches here, it's going to go through the light bulb. And then we have a long wire going down to a spring. Spring way down here at the bottom. It's kind of hard to see. But that spring makes sure that we have good contact with the batteries. And we have two batteries in a row here. So I'm going to draw two symbols. And then it goes back like that. How does the game operation work? I hope that you've all had an opportunity in life to play this kind of a game. And if you take the cardboard off, you can see that we have a relatively simple circuit. We have a big sheet of paper, sheet of aluminum that can act like one big wire. And up here, the wire branches. We have one part going to a motor and one part going to a light bulb. After that, the wires come back together again to two batteries, and then the tweezers. The tweezers act as a switch. If they touch the side of the hole, electricity can flow from the batteries out to the light bulb and then back to the batteries. The batteries are kind of dead right now, so they don't have enough power to light up or to move the motor, but that should be going right now. Anyway, it's kind of good that the factory designed it this way so that if either the light bulb or the motor breaks, you can still have current flowing through the other thing, and you can still play the game even though one item is bad. So to draw this, we would have a switch to represent the tweezers. And then we have a branch that goes either to the light bulb or it goes to the motor. And then it goes to the two batteries, one after the other, and back to the switch. So at this time, you can go on to homework D. 12 problems, and then on the next page it goes up to 19.